Another blank piece of paper. And this is called life terms. Life terms. And the little subheading is collecting them. And before you understand like terms, you probably need to figure out what are terms. What is a term? Anybody got a definition of a term for me? And let me give you something. Like let's say I've got this little phrase here. 3xy plus 8x minus 7y plus 18. This is like in English. You don't get an answer for this. You can't tell me that x or y is 6 or whatever. It's like an incomplete sentence, a fragment, a run, if you will. But what you must understand is this. You can sometimes simplify them, make them easier to understand. Okay. Back to what is a term. Terms are separated by addition and subtraction signs that are not in parentheses. This has 4 terms. This is a term, this is a term, this is a term, and this is a term. You always take the sign that's in front of them, not behind them. Okay? So this is like a positive 8x, this is like a negative 7y, that's like a positive 18, that's like a positive 3xy. Okay? If I had this, 3x plus 2x minus 6. How many terms are there? How many? Brand?
3.
3. And I would suggest, if it helps you for a little while, at least to circle them. Positive 3x is a term, positive 2x is a term, and minus 6 is a term. Okay? Now here is where people struggle. We need to figure out what are like terms. In math, we use this phrase a lot. Like terms are terms that have exactly the same, let's go letters. I was going to say variables, but letters to the same exponents. And that simply means this. Like terms. Terms with exactly the same letters to the same exponents. In order for something to be a like term with this, it doesn't matter the number in front, it only matters the letter. In order for something to be a like term, it would have to just be a number that has an x after it. Okay? This and this are called like terms because their exponent or their variable is just an x. Okay? If it was this, 3x squared plus 2x minus 6, these are not like terms because it has to be letters with the same exponent. That has an exponent of 1, that has an exponent of 2. Those are not like terms. Like terms must be, they could look like this. It could be 3xy plus 2yx. Those are like terms for the simple reason that, does anybody know why they're like terms? Wade?
Same letters.
They are the same letters, but they don't have to be in the same order because in multiplication you can flip-flop things around and not change anything because of the commutative property. So 3xy is the same as 2xy. Now, going back to this first one here, let me erase this. When you have like terms, if you have like terms, you can, what the book calls them, collect them. And for some reason, I don't know, that must be some politically correct term, because when I was a kid, they called it combining like terms. Or in Carter Westfall's jargon, combining like terms. that's why they got rid of it, because combine was too close to combine, I don't know. Okay. And here's the deal. I can't tell you how many people just struggle with this, and I'll try to get it as best I can. If you have 3x plus 2x minus 6, okay, what does 3x mean? 3x means that I have 3 x's. Just like this. If you have 3 times 2, what does that mean? You have 2 3's added together. 3 times 2 is 6, because 2 plus 2 plus 2 is 6. 3 x's mean you have 3 x's added together. Not multiplied, but added together. Here I have 2 more x's added together. Well, these are like terms. I can put all of those together. 3 x's plus 2 x's gives me a grand total of 5 x's. I have collected these terms. I have combined those terms, and I get 5x. 6 does not go with anything else, unless you'd see another number there somewhere, so it is only simplified like that. 3x plus 2x is 5x. Because you have 3 of them, you add 2 more of them, you get 5. Okay? So let's see what else we have here. So if I had this, 8y minus 2y plus 5x minus 6x plus 75. Looking at all those terms, the first thing you ask yourself is, are there some like terms? Are there some terms that have the exact same letters to the exact same exponents? Tyler says,
yes.
which ones?
8y and 2y and 5x.
Yeah, these two are alike. And what happens when I combine them? Hopefully the moisture content's not too high and I get the best price possible for that. If you have 8 y's and you take 2 y's away, you're subtracting 2 y's, you're going to end up with, Carter W? 6 y's. Now these two are also alike. If you have 5 x's, but you have to be careful here, you have 5 x's, but you're taking 6 of them away. Okay. Really what you have to think is you're just adding the numbers in front of the letters together. What do you get when you add 5 and a negative 6 together? Wait?
-1.
-1. But we don't usually put a 1 in front of it. If it's just a 1, we just put the x. And then the 75 just gets tacked on again because it doesn't. If there was another number, I could put them together, but there's not. So 6y minus x plus 75. Right out of the book. Well, there's no problem right out of the book. Right out of the unfair book. X plus y plus, oops, sorry, x plus y minus 1 minus x plus y plus 1. If the book says to collect those terms, the book says collect terms. What would you get if you combine, put all those together, the ones that you could put together? Look for the same letters. First of all, ask yourself how many terms are there. I see 1, 2, 3, 4, 5, 6 terms. Which ones can be put together of those 6? Brant, what can I do?
The 2 x's.
What do I get if I take x and minus x?
0.
0 x's, which you don't have to write down. It doesn't make any point to write 0 x's down because 0 times 19 is nothing. So it goes away. I'm done with my x's. Now I have, Jacob?
2 y's.
2 y's, which is 2 y's. And then I have a minus 1 plus 1, Parker, which is?
-1 plus 1 is 0.
0. So they go away and you're left with just a 2y if you collect those terms. Oh, here's a good one. How about this one? How about 3x plus 2xy plus xy minus x? You're asked to collect those terms, or collect, or combine, or combine. What would you get if you put together what you can't put together there? What say you, Evelyn?
Well, 3x and minus y, just do 2x then.
Wait, 3x minus what?
No, never mind.
3x minus x, right?
Yeah,
You said
that's
minus
what-
y, I don't see a minus y, there's just 2x, that is correct.
Oh, okay.
And then 2xy's plus another xy, Amelia, is
Plus 3x.
3xy's plus 3xy. 2 here plus 1 there is 3xy. Is there another one? Oh yeah, here's one with some exponents, let's do this one. 2a cubed plus 3b minus a cubed minus 4b. I guess that's it. What do you get if you collect like terms there? What would you get for that? What, pray tell? How about for the a cubes? What, Tyler, do I get a cubed by?
I have 2a to the 6th power,
Nope.
9th power.
Now, let me ask you a question, because that's what happens, I'm glad you said that. When I put this x with this x, did those turn into x squareds?
No.
Okay, same thing here. You have 2a cubes, that means you have this. And you take away 1a cube, nowhere do they change, their exponents don't change. These are all a cubes. A cubed plus a cubed minus a cubed means you have 1a cubed left over, plus 1a cubed, so it doesn't matter. They don't, you're not putting, you can't put their exponents together. That's multiplying. A cubed times a cubed is a to the 6th. Let me ask you a question. When you had 3b minus 4b, did you put minus 1b squared? So why did you do anything with the exponents here?
I don't know.
Oh my. And then a minus 3b minus 4b is a minus b. But that happens a lot. You're not the only person that does that, but I'm glad you actually said it, because that happens. You know, 5x squareds plus 3x squareds is not 8x to the 4th. It is 8x squareds. Because this 5 means you have 5 of them. They don't change. Their exponents don't change when you add them. When you multiply, yes. Because x squared times x squared is x times x times x times x. How many people put it? B to the 6th or whatever, a to the 6th. Anybody else? To be honest, I know it happens. Believe me, that's why it's tough. So here's what you're going to get. Check this out. And this is why this is going to be. What is the perimeter of this rectangle? What is this? If the book asks you to give the perimeter of that rectangle whose sides are x and 3y, how will you find the perimeter of that? Well, perimeter is adding up all the sides. So if that side over there is x, this is x. If that top is 3y, this bottom is also 3y. So to find the perimeter, it's going to be x plus 3y plus 3y. What do you get if you simplify that or add all of those together? Abram?
8.
8. That would be 3 plus 3 plus 1 plus 1, but it's not. Not sure where 8 comes from. Cartwright?
2x plus 6y.
Correct. You put the two x's together to get 2x. Then you have 3y's plus 3y's, that gives you 6y's. That's as much as you can do. Unless you know what x is and unless you know what y is as numbers, you can't do those together. What if I asked you for the area of that rectangle? Anybody know what it would be? What is area? Area is length times width. What if we multiply the length times the width? Evelyn?
3xy.
Yep. Area would just be 3xy. Whatever unit squared, maybe inches squared, whatever it is. That's all you can do. If you don't know what the numbers are, you just have to leave them as numbers. It's a learning process.